Hey guys, I welcome you to NEET World. In this session, we are going to see the NEET PYQs. Okay. Excuse me. Yeah. So before going into the topic now, let me once again tell you that the NEET World Institute, like our institute is going, like has started the process of the second intake. This is in the July 15th, that is this is today. Okay, like the process is going on. So if you want to know the process now, you can call this number, or else you can visit the offline branch which is located in Hyderabad, Narayanguda. Okay, so let me go into the topic, that is most repeated NEET previous year questions. So yesterday we have stopped up to some questions, right? So we'll continue from that. Yes. Okay. So this is the first question of today's session. The question is, the amount of energy required to form a soap bubble of radius 2 cm from a soap solution is nearly. So the surface tension of a soap solution is 0.03 Newton per meter. Okay. I need to find the energy required, no? Okay. So let me tell you the first thing. So whenever this kind of question is asked, no, like the soap solution they are asking, soap bubble, no, soap bubble in the sense which will have two surface, soap bubble having two surface, so both inner and outer. Okay, both inner and outer. So what is the circumference of the soap bubble or sphere? The sphere, right? Circumference. Yeah, but we need to know about the area, no? So area is nothing but area of the sphere is 4 pi r square. 4 pi r square. So now the work done, if I find, I can find the energy required, right? Energy required. So what is the work done formula? First of all, work done is equals to force into displacement, right? But they have mentioned is tension. I will take tension, that is tension into the how much area it is, 4 pi r square. But one thing is, it is having two surface, right? So into 2. So 2t 4 pi r square is the work done formula. If I find it, I will get the energy required to form a soap bubble. So how much work done it has been taken place to form a soap bubble. So what is the given things here? Tension is equals to 0.03 Newton per meter, and then radius is given as 2 centimeter. No, I need to convert it into meter, which is 2 into 10 power minus 2 meter. Now what are the things I need? That's it now, tension and the radius. So I will substitute the values now. 2 into 0.03 into 4 into 22 by 7 into 0.0 to the whole square. So if I calculate this, I will get the value of work done. This is the energy required to form a soap bubble. This is the energy required to form a soap bubble. So what are the formula we have learned here in this? The work done required to form a soap bubble, that is T into 4 pi r square, that is area of the sphere, and y it is into 2, which is having two surface, both inner as well as the outer surface. Yeah, this is surface area. Yeah, I mentioned no area, surface area. You can note down and give answer for that. What is the answer for that? Yeah, you can take this one as 22 by 7 or also 3.14 also. 3.14 also you can take it. That's no issue of that. Okay. So calculation you can do it and give the answer in the comment box, we'll check it. Okay, we'll go for the next question. Can we go for the next one? Okay, so the next question is, yeah, a copper rod of 88 centimeter and aluminum rod of unknown length have their increase in length independence of in temperature. The length of aluminum rod is, okay, so coefficient of copper has been given and alpha A aluminum also has been given, right. One thing they have said, it is independent of their temperature. It means both are having equal expansion, can I say, both are having equal expansion. Now the thing is delta L, yeah, delta L copper, right, into alpha copper should be equals to, because it is independent of temperature, the change in temperature they have not mentioned, it is independent. So I can take delta L into alpha can be equals to delta L aluminum into alpha of the aluminum. Okay, coefficient of linear expansion, no, alpha is nothing but coefficient of linear expansion. Okay, now what is the change in length? Like I have said, change in length will be equal, right, when it is independent of temperature. So length of copper into alpha, like coefficient of linear expansion of copper should be equals to length of aluminum, coefficient of linear expansion of the aluminum. So here we know the length of copper and coefficient of linear expansion of the aluminum, copper also given and aluminum also given. So from this equation, no, I can find the length of aluminum here. So what will be the length? Length of aluminum should be equals to length of copper and coefficient of linear expansion of copper divided by coefficient of linear expansion of the aluminum. Okay. So can I substitute the values directly now? So 88 centimeter has been given, right. So what is the answers are given in centimeters only. So directly I can take in centimeters. No need to convert anything. Okay. Now the thing is length 88 into, so this is 1.7 into 10 power minus 5, 2.2 into 10 power minus 5. So minus 5 I can cancel it out. So 1.7 divided by 2.2. Okay, 1.7 into 2.2. So what will be the answer? Final answer. Length of aluminum. Final answer. Give the answer. Answer for this question. Yes, it is 68. It is 68. Option C, right? 68 centimeter. Okay. Can we go for the next one? Can we go for the next question? Guys, whoever watching in online also know, you can give the answer in comment boxes. We'll check it and we'll check whether it's right or wrong. Okay. Oh, fine. The next question is, the approximate depth of an ocean is 2700 meter. The compressibility of water is 45.4 into 10 power minus 11 Pascal, like Pascal inverse, and the density of water is 10 power 3 kg per meter cube. Find the fractional change in volume. So fractional change in volume in the sense delta V by V they are asking, right? Fractional change in volume. Where is the pen? It's coming. Yeah, came. So fractional change in volume. So they are asking about delta V by V. So what is the formula for that? Which is equals to beta into delta P, right? Beta into delta P. So what is beta here? Beta is nothing but compressibility of the water. Beta is nothing but compressibility of the water. Okay. And what is the delta P? Like pressure has been given here, No, they have not mentioned, right? So I need to find the pressure. What is the formula to find the pressure? So pressure is equals to rho g h. Rho g h. What is the density is given? Density of the water is 10 power 3 kg per meter cube, and depth is given as 2700 meter. So I can take g as either 9.8 or 10 meter per second square, right? So what will be the answer? 10 power 3 into 10 into 2700 meter, 2700 meters, right? So which is equals to 1, 3, 4, 5, 6. So 2.7 into 10 power 7 I can take, no, 2.7 into 10 power 7. Now the beta is given as 45.4 into 10 power minus 11 Pascal inverse. So this one is Pascal, okay, pressure is in Pascal. Now delta V by V is equals to 45.4 into 10 power minus 11, 10 power minus 11, right, 10 power minus 11 into 2.7 into 10 power 7, 2.7 into 10 power 7. So if we calculate this, we will get the fractional change in volume, we will get the fractional change in the volume. Kabir Sir ji, namaste. Namaste, namaste Kabir. Namaste. Yeah, you can give answer for this, Kabir. 4.5 into 10 power minus 11 into 2.7 into 10 power 7. Yeah, you can give the answer for this question. What's the answer? Yes, the answer is 1.2 into 10 power minus 2. 1.2 into 10 power minus 2 is the answer. Approximately we will get 1.2 into 10 power minus 2. Can we go for the next question? Okay, you can take a formula this, that is delta V by V is equals to beta into delta P, like fractional change in volume. Okay, the next one is, the next question, two wires are made of the same material and have the same volume. The first wire has the cross sectional area A and the second wire has the cross sectional area 3A. If the length of the wire, like first wire, is increased by delta L on applying a force F, how much force is needed to stretch the second wire by the same amount? Okay, so the thing is given here, it is same material and have the same volume, same material and same volume. Okay, so initially what they have said, like area A and length is, yeah, it is L. So second one is 3A. What will be the change in length? Like how much length it will be increased? How much length will be increased? Yeah, volume constant, right? Volume constant. Volume is constant. So I can say like this one, no? If volume is constant, so if volume is constant, A into L should be equals to, what is the area for second wire? It is 3A. 3A into, I don't know the length, right, for the second wire, how much length? It is L2, I will take L2. From this I can get what is L2, right? So A and A will get cancelled. So L2 will be equals to L by 3. This is the length of the second wire. Now they are asking how much force required, no, to stretch it. So formula is like, we know that Young's modulus equals to force stress by strain, no, force by area divided by change in length by original length. Change in length by original length. Right. So from this I can find easily. Right. So initial force is nothing but yeah, I can rewrite this one now. So this one will be y is equals to F by A into L by delta L or delta L by L. So if it goes upward, no, it will become delta L by L, I guess. Right? Is it? No, right? It is L by delta L. Yeah, L by delta L. Okay. Now from this force equals to y A delta L by L. Okay, this is the initial force, guys. Now I need to find the how much force it has been increased or decreased, whatever it is. Now I will take this as F as it is. Now F1 will be F1 or F2. F2 I will take. F2 should be equals to y into how much area? That is 3A. No, 3A area. 3A into delta L by how much length it is? L by 3. So from this equation can I write F2 is equals to 9 YA delta L by L, where YA delta L by L is nothing but F. So F2 is equals to F9. So 9 times the first force. Yeah, it's correct. 9F Kabir. You are correct. 9F is the answer. Can we go for the next question? Is it clear? No. The one thing is you need to know whatever the question is said, like same material and same volume. So same volume. So I have taken A into L should be equal to 3A into L2. Okay. How much area it has been expanded, how much length it has been expanded or decreased, whatever it is. So both are equal since volume is equal. So L2 will be equal to L by 3 and A is nothing but like A2 is nothing but 3A. So from that for first force it is YA delta L by L, and the for second thing A is nothing but 3A and L is nothing but L by 3. So if I take, it will become 9 times the first one. 9 times the first one. Okay, can we go for the next question? Yeah. Okay. Now a wire of a length L, area of cross section A is hanging from a fixed support. The length of a wire changes to L1 when mass M is suspended from its free end. The expression for Young's modulus is. So what is the formula for Young's modulus? It is stress by strain, we know, right? So they are asking what is the expression, right? Expression, yes, it is Young's modulus equals to stress by strain. So what is stress? Force by area. Force by area divided by strain is nothing but change in length by original length. Change in length by original length. Am I right now? Now it is hanging. No, what they said, it is hanging from a fixed support. So what will be the force? Force formula we know, F is equals to mass into acceleration. So here I will take acceleration as like the gravity. Okay, it's hanging. So mg I will take. Mg. So as of now I have no the force. I will keep as it is. They have not, like they have mentioned the cross section area as A. Okay. What is the length? Like that is, yeah, L1 it has been changed. Initial is L. It has been changed to L1. So it is L1 minus L. No. L1 minus L. So delta L will be equals to L1 minus L. Now substitute the whatever values you have in that in this equation. So y will be equals to F into F into L by A into delta L, right, delta L. Now what is F? It is mg. What is L? As it is L, right, okay, it is initial length. Now what will be the area? They have given cross section area is A. The length is, like change in length is L1 minus L. So this is the expression for the Young's modulus, whatever they are asked in the question. So which is the correct option? So this one, option A won't come, option B, option C also won't come, option D, L1 minus, it's below. So option B is the correct answer, right? Option B is the correct answer. The simple thing is, we need to know what is the formula for Young's modulus and stress and strain. So stress is nothing but force by area, strain is nothing but change in length by original length. So whatever the things they have given, we have substituted. So change in length to L1, initially it is L. So delta L will be L1 minus L. I hope you got this answer, right? I hope you understood the method also what we have followed, right? Can we go for the next question? Can we go for the next question? Yes. The next question is, a soap bubble having a radius of 1 millimeter is blown from a detergent solution having a surface tension of 2.5 into 10 power minus 2 Newton per meter. The pressure inside the bubble is equal to the pressure at the point Z0 below the free surface of water in a container. Okay. Taking G is equals to 10 meter per second square, density of water is 10 cube kg per meter cube, the value of Z0, okay, Z0 is nothing but, no need to confuse here, it is the height they are asking. See, the pressure inside the bubble is equal to the pressure at the point Z0 below the free surface of the water, okay. So if the container is there, know how much pressure they are asking in the depth of height h. H is the Z0 they have mentioned, okay. So what is the excess pressure? Excess pressure formula here. Excess pressure of soap bubble formula. So it is, excess pressure formula is delta P is equals to 4T by R. Yes, 4T by R, where T is the tension, okay, and R is the radius of the soap bubble, okay. Now if I find the pressure, I can use that formula like P is equals to, delta P is equals to rho G H, where H is equals to delta P by rho G. Am I correct now? So from this, H is nothing but Z0. If I find H, I will get the answer for that question. So for this, what is the tension given? Surface tension 2.5 into 10 power minus 2 Newton per meter. So 4 into 2.5 into 10 power minus 2 divide by, what is the radius? 1 millimeter. I need to convert into meter, right? So I will say a simple trick. This is 1000, kilometer, meter, centimeter, millimeter. Okay. So this is 1000. So reduce 1 0, it is 100, and reduce 1 0, it is 10. So kilometer to meter 1000, 10 power 3, meter to centimeter 10 power 2, centimeter to millimeter 10 power 1. So if I want to come from millimeter to meter, how much it is? 10 power minus 3. So keep in mind this one. So you can do whatever conversion they are asking, okay. Kilometer, meter, centimeter, millimeter, 1000, 100, 10. When you are coming from this side, you should take in positive 10 power 3, 10 power 2, 10 power 1. When you are going from millimeter to kilometer, 10 power minus 3, 10 power minus 2, 10 power minus 1, like that we will take, okay. Now, so 10 power minus 3, right. So what will be the thing here? Yeah, 10 power minus 3, okay. Now from this, I need to get the pressure value. What is the pressure value? 2.5 into 4. What is the answer? 5, 10, right? 10 and 2.5 into 4 is 10 into 10 power minus 2 into 10 power 3. So 10 power 4 and this is 10 power minus 2 which will be equals to 10 square. Okay. So this is the pressure. I will keep as it is. Now the H value is equals to, so this is 100 divided by, what is the value of density? 10 power 3, no, 10 power 3, and what is the value of gravity? This is 10 into 10. Okay, this is the values. Now yeah, 1 0 and 2 zeros will get cancelled. Here 2 zeros I have taken, here 2 zeros I have cancelled out. 1 by 100 which is equals to 0.01 meter, right? Meter. So it is 1 centimeter, 1 centimeter. That's the answer, 1 centimeter. This is the height. This is the height they are asking. 1 centimeter. So Z naught is 1 centimeter. The value of Z naught is 1 centimeter. So the formula we have learned here is the excess pressure, that is delta, sorry, excess pressure for the soap bubble. Delta P is equals to 40 by R. So from that, one more thing is delta P is equals to rho GH, where I need to find the value of H. So before that I need to find the value of pressure. So for pressure, 4 into tension by the radius, and that I have substitute the value of pressure in this equation. H is equals to delta P by rho G. And the thing is, you need to remember the conversions, especially the conversions you need to remember. So whenever they are giving the question, see the units, whatever the units they have given, either it is meter, millimeter, centimeter or kilometer, convert everything into one unit. At last, if they are asking about the answer, like answer is given in either centimeter, millimeter or whatever it is, again you can convert later. Okay. Can we go for the next question? Okay, can we go for the next question? Yeah. The two ends of a metal rod are maintained at temperature 0 degree Celsius and 110 degree Celsius. The rate of heat flow in the rod is found to be 4 joules per second. Okay. If the ends are maintained at temperature 100 degree Celsius and 210 degree Celsius. Okay. So initially 0 and 110 and the heat flow was found to be 4. Now the temperature is 100 and 210. The rate of heat flow they are asking now. So first of all, what is the temperature difference for the first case and second case? First case temperature difference is excuse me, yeah, case 1, temperature difference. So it is 110 minus 0. Excuse me, sorry guys, 110 minus 0 degree Celsius. So which is equals to 110 degree Celsius. What about the case 2? This case 1, right? Case 2, the temperature difference is nothing but 210 minus 100. 210 degree Celsius minus 100 degree Celsius, which is equals to the same answer I am getting, 110 degree Celsius. So for the first one, heat flow was found to be 4. For the first case, it is 4. That is 4.0 joules per second. Since the case 1 and case 2 having the temperature difference same, I will get the same heat flow. Okay. It is 110 degree Celsius. The second case also 110 degree Celsius. Since both are having the same heat flow, I will get the same temperature difference, I will get the same heat flow. Okay. Understood now this question? So what will be the answer? Option A is the answer, right? 4.0 joules per second. So as of now we have seen many questions. Now I'll give one question for homework. Okay, 1 mole of an ideal diatomic gas undergoes a transition from A to B along a path AB as shown in the given figure. The change in internal energy of a gas during the transition is. You can try this question and give answer in the comment box. We will check it whether the answer is right or wrong, and I will explain you the process in next session. Okay, this is the homework question. You can try it. Okay. Okay guys, we'll stop up to this, and the next session is going to start from 11:50, that is the 100 days challenge of the physics. Okay, we'll go with the next topic of that physics. Okay, okay guys, bye bye, we'll see you in 11:50. Bye. You can take a screenshot of this. Okay, give answer in the comment box, we'll check it. Bye guys, take a short break, come exactly at 11:50, we'll meet.